Hidden beneath the calm, shimmering waters of New Zealand's largest lake lies a force powerful enough to reshape landscapes and influence the planet itself. At first glance, Lake Taupo appears peaceful. Its wide blue surface reflects surrounding forests, distant mountains, and quiet holiday towns. But beneath that tranquil water rests one of the most powerful volcanic systems on Earth. Taupo is not just another volcano. It is a supervolcano, capable of eruptions far larger than anything humans have witnessed in modern history. Roughly 1,800 years ago, Taupo erupted with extraordinary violence. Ash and gas blasted high into the stratosphere, darkening skies across large parts of the Pacific region. The eruption was so powerful that its deposits can still be traced across New Zealand today. And long before that, around 26,000 years ago, Taupo produced an even greater catastrophe, one of the largest eruptions known in the last 100,000 years. The event reshaped the geography of New Zealand and filled the atmosphere with ash, triggering a volcanic winter across huge regions. Today, the lake hides the collapsed crater of that massive eruption. But Taupo is not extinct. Deep underground, magma slowly moves and accumulates. The earth beneath the lake subtly rises and falls over time. Small earthquakes occasionally ripple through the region, quiet reminders that this enormous volcanic system is still alive. If Taupo were to awaken again, what would happen? How much warning would scientists have before a major eruption begins? And could such an event affect not just New Zealand, but the entire world? Let's explore the science behind one of Earth's most fascinating and powerful volcanoes. And if you enjoy deep dive science and geology stories like this one, consider subscribing and liking the video. It's one of the best ways to support the channel. The birth of the Taupo supervolcano. Taupo sits within the Taupo volcanic zone, a highly active geological region stretching roughly 350 kilometers across New Zealand's North Island. This area exists where two enormous tectonic plates interact. The Pacific plate slowly dives beneath the Australian plate, a process known as subduction. Normally, subduction zones create chains of steep volcanic mountains, but the central Taupo volcanic zone behaves a little differently. Here, the Earth's crust is also being pulled apart. This stretching thins the crust and allows extremely hot magma rich in silica to rise from deep underground. Over time, huge magma reservoirs develop beneath the region. Every so often, pressure inside these reservoirs becomes too great. When that happens, the crust above can fracture and collapse, releasing massive eruptions that eject hundreds of cubic kilometers of volcanic material into the atmosphere. These events are known as super eruptions. In volcanic science, eruptions are ranked using the Volcanic Explosivity Index, or VEI. The largest category, VEI 8, represents true super eruptions. These events release more than 1,000 cubic kilometers of material, enough to blanket continents in ash and disrupt global climate systems. Taupo is one of the few volcanoes on Earth capable of such an eruption. Taupo's ancient catastrophe. The most dramatic event in Taupo's history occurred around 25,500 to 27,000 years ago. Scientists call this eruption the Oruanui eruption, and it ranks among the largest known eruptions in the last 70,000 years. During this event, enormous pyroclastic flows raced across the North Island. These were scorching clouds of ash, rock fragments, and gas traveling at hurricane speeds and temperatures of hundreds of degrees. Anything in their path would have been instantly destroyed. Ash from the eruption spread across both the North and South Islands, covering vast areas in thick volcanic deposits. The eruption dramatically altered river systems and reshaped the surrounding landscape. Valleys formed, drainage patterns shifted, and enormous layers of volcanic rock blanketed the region. When the eruption ended, the emptied magma chamber beneath the volcano collapsed. This collapse created a massive depression in the ground, a caldera, which eventually filled with water. That caldera is now Lake Taupo. The eruption of 232 CE, although the Oruanui eruption was the largest, Taupo did not remain quiet afterward. Around 232 CE, the volcano produced another enormous eruption known as the Hatepe eruption. While smaller than Oruanui, it was still incredibly powerful. roughly a VEI-7 event. In fact, it may have been the largest eruption on Earth in the last 5,000 years. The eruption column likely rose more than 40 kilometers into the atmosphere, reaching the stratosphere. If an eruption like that happened today, it would shut down air travel across large parts of the southern hemisphere. The eruption also generated powerful pyroclastic flows and widespread ashfall across New Zealand. Inside the lake itself, massive disturbances may have triggered tsunami-like waves, sending water surging across the shoreline. Thick layers of ash buried nearby landscapes, dramatically altering the terrain. Over time, those volcanic soils became incredibly fertile. Today, they support forests, farms, and thriving ecosystems across central New Zealand. Most importantly, this eruption occurred within the last 2,000 years, reminding scientists that Taupo is not just a relic of ancient geology. It is an active volcanic system. Modern signs of activity. Although Taupo has not erupted since the Hatepe event, it still shows signs of activity beneath the surface. Modern monitoring reveals swarms of small earthquakes beneath and around the lake. These quakes often occur in clusters and may signal movement of magma or fluids underground. For example, in 2025, scientists detected a swarm of dozens of small earthquakes near the northern side of the lake in a geothermal area. Most were minor with magnitudes below 3, but they demonstrate that the volcanic system is still adjusting and shifting. In earlier unrest episodes, including activity between 2022 and 2023, the region experienced earthquakes reaching around magnitude 5.7, among the strongest recorded beneath the lake in decades. Scientists also observed ground deformation in the region. Using GPS and satellite measurements, they can detect when parts of the landscape slowly rise or sink over time. These changes often indicate pressure variations deep within the magma system. Geophysical studies show that beneath Taupo lies a partially molten magma body, confirming that large volumes of magma remain beneath the volcano. Additionally, geothermal features around the lake, including hot springs and steam vents, reveal the presence of intense underground heat. Together, these clues show that Taupo is not dormant, it is simply resting between eruptions. Could Taupo erupt again? The question scientists often hear is simple. Will Taupo erupt again? From a geological perspective, the answer is yes. But predicting when is far more complicated. Super eruptions are incredibly rare. On average, events of VE8 magnitude occur somewhere on Earth, perhaps once every 50,000 to 100,000 years. Taupo's last super eruption happened around 26,000 years ago, while its most recent major eruption occurred about 1,800 years ago. These timescales are enormous compared with human history. Because large eruptions require huge amounts of magma to accumulate over thousands of years, scientists believe a future super eruption would likely show major warning signs decades in advance. However, Taupo does not need to produce a super eruption to be dangerous. A VEI-5 or VEI-6 eruption, similar to Mount St. Helens in 1980 or Mount Pinatubo in 1991, would still have devastating regional effects across New Zealand. Events of this size are much more likely on human timescales. How scientists monitor Taupo. Fortunately, Taupo is closely monitored by one of the most advanced volcanic observation networks in the world. Scientists track the volcano using seismometers that detect earthquakes, GPS instruments that measure ground movement, satellite radar that maps subtle surface changes, gas sensors that monitor volcanic emissions, lake-level sensors, and hydrothermal surveys. All this data feeds into New Zealand's volcanic alert system, allowing scientists to detect early warning signs of unrest. Many volcanoes show clear precursors before erupting. These can include increasing earthquake swarms, rapid ground uplift, rising gas emissions, or sudden changes in geothermal activity. While volcanoes can still surprise researchers, modern monitoring greatly improves the chances of detecting a developing eruption early. The future of Taupo remains one of Earth's most impressive geological systems. Hidden beneath a beautiful lake lies a volcanic engine capable of reshaping landscapes and influencing global climate. Over the past tens of thousands of years, it has produced some of the largest eruptions our planet has seen. Yet today the region is home to vibrant communities, thriving wildlife, and one of New Zealand's most popular travel destinations. The story of Taupo is ultimately a story about deep geological time. Its cycles of magma buildup, eruption, and quiet dormancy unfold over tens of thousands of years, far longer than human civilizations. While a future super eruption is possible someday, scientists do not expect one anytime soon. More likely, Taupo will continue its long periods of calm, punctuated occasionally by smaller but still significant eruptions. And as long as scientists continue watching closely, humanity will be better prepared for whatever this sleeping giant chooses to do next.